Uh, a very good morning. Today we are trying to cover, we are looking from the AWS Certified Security Specialty. So this particular video is intended for the people who wish to qualify this particular certification in their very first attempt. So we'll be looking at a variety of questions which might give you a very high degree of the exposure and familiarity with the kind of the questions you can anticipate in the examination. So this is the sectional. We are looking at these various sections. As you might be aware that there are 5 sections within the security specialty. So this particular resource might be very valuable in order to augment your preparation. So without any delay, we will get started with this. So a security engineer is tasked to set up an automated security alert for the systems hosted in the AWS. Both the security and the operation team should immediately receive an alert if there are too many unauthorized AWS API requests identified on certain time frame. Which of the following is the most suitable solution that an engineer should do in order to satisfy the above requirement? Set up the schedule job that runs on the Amazon Athena every hour against the CloudTrail log files hosted in the and use the Amazon QuickSight to analyze the results from the Amazon Athena. Use the unauthorized AWS API request manage rule in the AWS config to detect the failed request. Enable the CloudTrail in the AWS account. Set up a CloudWatch metric filter that monitors the API call error codes and create a new watch based on the metrics trait and send the notifications using the Amazon SNS. Since most probably we're talking about the AWS API request and unauthorized AWS API request identified on a certain time frame, we are looking at the CloudTrail as one of the service, and we can always set up a CloudWatch metric filter that basically monitors the API call error codes, and we can create an alarm so that we will be getting some kind of notifications while leveraging Amazon SNS. A government entity developed an online portal for gathering population and migration data in your city. Each household information uploaded on the portal is stored in the encrypted files in the Amazon S3 bucket. The indexes are saved on the DynamoDB. The government also wants to verify that the data access configuration meets the strict compliance standards. They should also be alerted if there is any risk of the unauthorized access and inadvertent data leaks. So if we can read the question very carefully, the government also wants to verify the data access configuration meets the strict compliance standards, and they should also be alerted if there is any risk in the unauthorized access and inadvertent data leaks. So the word inadvertent data leaks is very important. So we might need to select one of the services which looks into the the sensitive or confidential information that is getting leaked or exfiltrated outside. Which of the following solution should the security engineer? So Amazon Inspector is nothing but the vulnerability assessment or security assessment service. So it is the incorrect answer. Amazon Guard Duty comes very close because we know that it's the threat detection service for all the unauthorized and the malicious activities. However, it is not correct in this particular scenario. Amazon recognition to monitor and recognize the patterns on your S3 data. This is again the incorrect answer. Amazon recognition basically tries to detect the pattern or tries to detect the image in the object of people. Try to recognize the object of the people in some of the images. So it is incorrect. So we will be using Amazon Macy because Amazon Macy is very important service if we are trying to detect or trying to determine the personally identifiable information, and it does leverage machine learning algorithms to let us know the confidential information is stored into the S3 buckets, and we can detect the usage patterns as well, and with the help of the Amazon Macy as well, right? So this is the correct answer in from our standpoint. Company is using the Amazon Guard Duty to continuously monitor their AWS resources for malicious activity, unauthorized port scanning, and other security vulnerabilities. Whenever they are pre-approved port scanning activities from the specific EC2 instances, the operation still receives Guard Duty events while the Amazon CloudWatch events. There is a new requirement to support alerts on these unauthorized to prevent any false positives. Must ensure that alerts should be sent for any unauthorized activity in AWS. So, for example, this particular scenario talks about that we are highly leveraging Amazon Guard Duty as one of the service for the threat detection. We intend to basically remove or reduce some of the false positives completely. So, how can we do that? Amazon Macy. So Amazon Macy, as we talked about in the previous question, is the completely different service as compared to the guard duty. So it might not block the notifications which are getting triggered as a result of the AWS guard duty, right? Install the Amazon Inspector agent on the EC2 instances. Again, this is the security assessment service. This might not help. If you can see the third option, attach elastic IP addresses to the EC2 instances and then add these addresses to the trusted IP list in the Amazon Guard Duty. Yeah, so this is the correct answer as of now in our case, because we can definitely add the trusted IP addresses in some of the IP addresses which we can trust or which are legitimate into our trusted IP list in the guard duty, so that we can completely avoid the false positives which are getting triggered as a part of the notifications. Okay, exclude and filter out the, so this is the correct answer in our case as of now. Exclude and filter out the IP addresses of the pre-approved EC2 instances owned by the security team in the AWS Cloud Trail. There is nothing we can do in the AWS Cloud Trail from this particular perspective. A multinational corporation is a public-facing online repository that is hosted in the AWS. A security engineer is tasked to set up a system that will automatically detect suspicious activities such as SSH brute force attacks or compromised EC2 instances that serve malware. What solution should engineer implement in order to meet this particular requirement? So if we can read the question very carefully, is tasked to set up a system that will automatically detect suspicious activities such as SSH brute force attacks in the compromised EC2 instances. So we already talked about there is one particular service which basically supports this, which basically augments in our threat detection related activities. So we will be definitely be using Amazon Guard Duty. Macy is nothing but, we already talked about for the personally identifiable information, to detect personally identifiable information using some of the algorithms. Amazon Detective is not going to help in this particular case. Amazon Guard Duty is definitely a right answer. Amazon WAF is nothing but the web application firewall. So we'll be talking about that particular thing in some of the other questions as well. The IT security team of an organization recently discovered that several employees place restricted data in the various S3 buckets without any authorization. The team needs to identify all possible S3 objects that contain PII and then determine whether this information has been accessed or not. Any data that may have been exposed would have a serious consequences of the organization. So even before we look at the options, it does talk about the personally identifiable information. So we might want to look at AWS Amazon Macy from the specific perspective, because it talks about the personally identifiable information, and in order to identify the personally identifiable stored in the AWS estate, this is one of the service we highly leverage. So now we look at the options. Enable the Amazon Inspector on the specific S3 buckets and perform the required data classification. And also, we have looked at Amazon Macy is one of the services which is responsible to detect or determine the personally identifiable information for the classification. As well. So Amazon Inspector is nothing but a security assessment service. So it's the incorrect answer. Set up the Amazon Athena to detect personally identifiable information. Amazon Athena is nothing but wherein you can run some of the SQL queries to extract the data out from your S3 buckets. So this is again incorrect in this particular case. Enable Amazon Macy on the specific Amazon S3 buckets and perform the required data classification, and use AWS CloudTrail to determine if the objects were personally identifiable have recently been accessed by tracking the GET API calls that are used to fetch these particular objects. So definitely we are looking at personally identifiable information. We really want to determine that, classify that information is PII or not. So this is the correct answer in our case, and we can then subsequently use AWS CloudTrail if the objects with the PII have recently accessed by tracking the GET API calls that are used to fetch these objects. Amazon Guard Duty is basically a threat detection service. It is not useful for identifying or classifying the personally identifiable information on the specific S3 buckets. Therefore, it is incorrect. A distributed web application hosted in auto-scaling group of the EC2 instances is retrieving messages from the Amazon SQS queue. The application works properly, but after a recent IAM policy change, the instances suddenly can no longer retrieve messages anymore. So therefore, with respect to this particular question, which of the following should be done, and we have also looked at after a recent IAM policy change. So which of the factors might be responsible? So we need to troubleshoot this particular scenario. So if you look at the very first scenario or an option, implement a multi-factor authentication. You can remember that we are using a EC2 role in order to retrieve messages from the SQS queue, right? However, multi-factor authentication is for IAM user identities, not for the roles. Attach Amazon SQS full access. So we need not grant the full access to the SQS in order to retrieve the messages. It might not comply with the principle of the least privilege, so we can easily skip this particular option. Ensure that SQS resource policy does not explicitly deny access to the IAM role. This is one of the important consideration. We definitely want to check whether policy is explicitly denying access to the IAM role used by the EC2 instances. Ensure the access ID and secret access attached to the IAM role that is used by the EC2 instances. Again, this is the programmatic access. Basically, we are using when we are leveraging the CLI or API. However, we will not be using, in case of the role, we normally use temporary credentials. We are not using the long-term credentials, so definitely it is out of the context here. And the fifth option is also true. We also need to make sure that whatever the policy we are attaching to the role contains a policy that allows access to the SQS queue. So these are the possible correct answers from our side. Okay. Security administrator is tasked to set up an automated system to manage the access keys in the company's AWS account. A solution must be implemented to automatically disable all the IAM users access key that are more than 90 days old. Okay, so we are talking about one of the scenarios, to rotate the access keys if it is already greater than, if it has already been more than 90 days. So let's look at the options. Go to the IAM dashboard, view the IAM users table and check the AWS access key age and disable the IAM user access key that are more than 90 days old. So you can definitely look at this particular option, but this is the manual option and does not make any sense in this particular case as of now. Develop a Lambda function that calls the generate credential report API to generate a credential report. Configure the function to use credential report to download the report and parse the CSV and check the keys with the user creation time for more than 90 days and disable the old access keys using the update access key API. So this is one of the correct options, and we will be looking at why it is a correct option. So credential report is something which basically talks about all the IAM users, and it basically gives you the visibility of the access keys as well. And for example, it talks about when this particular access key has been created, or when this particular user has been created, and when this particular key has been used last for any of the AWS services. So this is one of the correct answer. We would definitely be relying on credential report to make the changes or to disable the old access key for our users. programmatically with the help of command line interface or an API. The other options talks about us use the access keys rotated manage rule in AWS config and set the max age to the 90 days. This is not the correct option in our context as of now. We can eliminate this particular option. Set up a CloudWatch alarm to detect access keys that are more than 90 days old and create a Lambda function that will be invoked by the CloudWatch alarm to disable the old keys. This is also the incorrect option in our case. So we will be relying on the credential report, and once we detect the access keys are already or have already been used for more than 90 days, we can definitely call some of the APIs to make the changes or to disable the old access keys or to replace with the new access keys. You have created a Lambda function that requires access to the RDS MySQL database. You did not store the database password inside your function code, but instead you stored it as a secure string type parameter. You have also added the SSM get parameter permission on an IAM execution role of your function to enable the retrieval. Upon testing, your API does not function properly and you suspected that database password is not retrieved when the function runs. Okay, so we are basically looking at AWS Systems Manager parameter store in this particular context. So let's see the possible correct options for this. Your Lambda function is not associated with the VPC where the RDS instance is hosted. You should use the Lambda environment variable configured with the default settings for the easy retrieval of the credentials. So the very first option is talked about function is not associated with the VPC. It's again, a Lambda function is never associated with one of your VPC, right? You can definitely eliminate this particular option. The Lambda function execution rules needs SSM decrypt parameter permission to retrieve and decrypt the password stored on the parameter store. So definitely Lambda function needs some of the permission to decrypt the secure string. We will be looking at that particular permission. However, this is not the correct answer in our case. The third option, the Lambda function execution needs a secret manager get secret value. So we are leveraging the systems manager parameter store, not the AWS secret manager. So therefore, it is an incorrect answer. However, if you look at the last option, the Lambda function execution rule needs KMS decrypt permission to decrypt the password stored on the parameter store. Since we are talking about a secure string, we would definitely be needing an permission KMS decrypt to perform cryptographic decrypt operation, so that we will be once we retrieve that secure string, it should also be into the plain text. A security engineer refactored an application to remove the hard-coded Amazon RDS database credential from the application and store it into the AWS Secret Manager instead. The application works fine after the code change. For improved data security, the engineer enabled the rotation. The change was done successfully without any issues, but after a short while, the application is getting an authentication error whenever it connects to the database. Okay. If we were to look at the options, the security does not have the secrets manager read write permission. So in order to comply with the principle of the least privilege, we will only be needing a permission in terms of get secret value. We don't need read and write permission. IMDb authentication was successfully turned off, so this is irrelevant in our context. Enabling rotation in the AWS Secret Manager causes a secret to rotate immediately. This is one of the correct answer. What happens is, if we are trying to use the credential which is stored in the AWS Secret Manager, if we have enabled the rotation, it basically rotated the password or the credential immediately in the AWS Secret Manager, and therefore sometimes we have issues connecting to the applications. And cloud so AWS Secret Manager, if it is storing the secured string or in the encrypted format, it basically uses the AWS KMS, not the AWS Cloud HSM. So Cloud HSM is definitely out of this context. We can eliminate this particular option number 4. The company has two Amazon EC2 instances hosted in the same VPC but placed in the separate availability zone. Each instance has a public IP address and is able to connect to the public internet. The two EC2 can communicate however, the security notice that these two instances cannot communicate with each other when using their public IP addresses. Okay, seems like a quite a simple scenario in our case. Let's look at the options. Add an inbound rule in the security group of the first EC2 instance to allow the public IP address of the second EC2 instance and vice versa. So we will hold on to this particular option because if we were to make these kind of the changes in the security group, these two instances will be able to communicate with each other with the help of the public IP addresses too, which is the requirement in this particular case. Attach a NAT gateway in a VPC that will allow two EC2 instances to communicate with each other using the private IP address. So we know the use case of NAT gateway. The NAT gateway is usually deployed in the public subnets, and you are using normally NAT gateways in order to grant access to the instances which are residing on the private subnet, so that they can talk to the internet or they can talk to the outside world with the help of NAT gateway, right? Even though they are residing on the private subnet, but they can talk to the internet. Basically, the outbound traffic should be enabled to the outside internet, but not the vice versa. Modify both the security groups of the EC2 instances to allow inbound access from the so again in our use case, we are looking at communication between the two EC2 instances using the public IP addresses. We need not make the entire internet available for this particular use case. You can easily eliminate this option. Create an inbound rule in the security group of the first EC2 instance to allow access from the second EC2 based on the instance ID and vice versa. So we know that normally we create the inbound rule and we mention either the CIDR range, or we mention the security group, or we need to mention the IP address. We will not be mentioning the instance ID for the inbound or outbound rules, right? So therefore it is incorrect. So the very first option is the correct answer here. A leading financial firm recently migrated their applications from their on-premises network to the AWS. The IT security team needs to implement a threat detection system that continuously monitors for malicious activity and unauthorized behavior to protect the firm's AWS accounts and the workloads. So by looking at the question itself, this is the very definition of nothing but Amazon Guard DoD, right? Because it's a threat detection service that continuously monitors for the malicious behavior or the activity which does not conform to the baseline. An organization is developing an AI-powered traffic monitoring portal that will be hosted on the AWS cloud. The IT security consultant was asked to implement the architecture and also set up a system that automatically assesses the application for exposure, vulnerabilities, and deviations. So this is a quite simple question here, and we know Amazon Inspector is basically used to do the security assessments or vulnerability assessments in order to identify the vulnerabilities or CVE scores, or whether it comply with the CIS benchmark or not. So definitely we will be looking at Amazon Inspector. Amazon Macy is nothing but is used to classify the data and used to determine the personally identifiable information stored on the objects. AWS Shield is nothing but, we will talk about AWS Shield a little later, basically used to defend against the DDoS attacks. Guard Duty we have already looked at, it's nothing but the threat detection service. A security engineer find out API logging was disabled in the corporate AWS production account. The engineer also noticed the root IAM user was used to create a new API without any approval. What should the engineer do to detect and automatically remediate these types of the security incidents? Set up a CloudTrail event that detects deactivation of the CloudTrail logs. Create another CloudTrail event that detects the creation of the root API keys. This option is incorrect because if you are trying to recollect, we do have the CloudWatch event rules, but however we don't have CloudTrail, nothing something of CloudTrail event. So this particular option is trying to make us confused. So it is an incorrect answer here. Create a CloudWatch event that detects AWS CloudTrail deactivation. Use Amazon Trusted Advisor checks to automatically detect the creation of root API keys, and set up the AWS Lambda function to re-enable the CloudTrail logs and deactivate the root API keys. So again, we will not be using Amazon Trusted Advisor to detect the creation of the root API keys. So this is the incorrect option here. We can definitely use CloudWatch event to notify us if somebody disables the CloudTrail. So this particular cloud event can send us a notification. However, uh, in order to activate the CloudTrail once again, we'll be needing to use a Lambda function, okay, which talks about in the later part of the question. But however, this answer is incorrect because Trusted Advisor checks to automatically detect the creation of the root API keys is incorrect. Create a config rule in the AWS config that detects when the AWS CloudTrail is disabled, and set another rule to monitor any calls that create API by the IAM user, and set up the AWS Lambda function to re-enable the CloudTrail and deactivate the root API keys. So if we look at the third part of the answer, this is definitely true. We will be leveraging the AWS Lambda function to re-enable the CloudTrail logs and deactivate the root API keys once again. And we can definitely use a so we are leveraging the config rules here, so basically which tells us about whether that particular CloudTrail is disabled or not. So this is the correct answer in this particular scenario. We should be using config rules for both the scenarios, and to address that and to remediate, in order to take the remediation actions, we will be leveraging the Lambda function to enable the CloudTrails as well as deactivate the root API keys. Amazon Inspector, as we know, it's a security assessment service, so it's irrelevant here. An organization allows most of its employees to work from home using their company issued laptops. There was a recent incident in which a developer's laptop, which does not have any encryption at all, was stolen. The device contains several SSH private keys that are used to access the Amazon EC2 instances in the corporate AWS account. The security administrator has a separate SSH private keys to access the instances. Okay, what should the administrator do to protect currently running EC2 instances? Okay, so we will be looking at some of the options which because the laptop is stolen and we would like to safeguard our EC2 instances. Because that laptop is stolen, if somebody is able to get into the system and is able to compromise the private keys, then it will be a problem. Our EC2 instance might get compromised. So let's look at an option. Log in into the Amazon EC2 console and delete the key pairs. If we were to select this particular option, it will only be deleting this particular key pair on the EC2 console itself. However, the same public key shall remain associated with the EC2 instance. So if somebody has got the copy of the private key of this particular key pair, he will be able to access the EC2 instance. Use the modify instance attribute command in the AWS CLI to change the associated SSH key of the affected EC2 instances. This is not the right answer in this particular case. So we looked at the second option, which is incorrect. Use the AWS System Manager run command to modify the authorize keys file for all the affected EC2 instances and remove all the public keys in the file that is associated with the compromise SSH private keys. So this is the correct answer in our case. We can definitely try to modify the authorized key file because we need to disassociate whatever the key the private key which has already been compromised. So we need to remove the public keys in the file that is associated with the compromised SSH private keys. If we were to look at the fourth option, use AWS config to easily disable the compromised SSH keys and block access to the affected EC2 instances. We can easily eliminate this option because AWS config will not block access to the affected EC2 instances. We need to use either if we want to explicitly block any of these, we might want to use the knuckles in this particular case, right? And AWS config will not be used to disable the compromised SSH key, so we can eliminate this option. So this is the correct answer in our context.